3. Statistical applications in environmental sciences. Module 5. Diagrammatic and graphical representation of data 2. Learning objectives. Introduction. Graphical presentation of frequency distribution. Stem and leaf plot. Pie chart. Summary. Suggested readings 1. Learning objectives. In this module, a complete explanation about different types of representation of data will be discussed. This module helps to learn different methods of diagrammatic and graphical presentation and their properties. Through this module, one can learn about which method to use under what conditions. Questions with answers are included to give an in-depth knowledge of the topic. 2. Introduction. In this module, one can get a depth knowledge of different types of diagram like pie chart and graphical representations of the data like histogram, frequency polygon, etc. This module is continuation of the previous module. Hence it is desired that reader must go through the previous module before further reading. We have already discussed about the frequency distribution and its different forms in the previous module. In this module, graphical representation of the frequency distribution and its types will be discussed. Other diagrammatic and graphical methods and their properties are also discussed. This module will help to develop an understanding of different methods of graphical and diagrammatic presentation of the data. In the following section, graphical presentation of frequency distributions are discussed in detail. 3. Graphical presentation of frequency distribution. Graphs which consider the frequencies for the presentation of the data are called frequency graphs. These graphs are used to describe the characteristic feature of the frequency data. The methods for the preparation of the frequency table is already discussed in the previous module. The frequency graphs usually depends on the type of data, whether it is discrete or continuous. Discrete data are usually represented in the form of bar diagrams or discontinuous curves, while the continuous data are represented by means of curves. While constructing the frequency graphs, usually the value of the variables are taken on the x-axis and the corresponding frequencies are represented on y-axis. The graphs that are used for this purpose are I. Histogram, E. Frequency polygon, E. ogives. 4. Statistical applications in environmental sciences. I. Histogram. It is among the most commonly used method for the diagrammatic representation of a grouped frequency distribution. On one axis it consists of bars with height proportional to class frequencies, and the width of the bar is defined through the class boundaries presented on the horizontal scale. In general, same width is considered for all the bars, but it is not essential as it depends on the class width. In histogram, there is difference in terms of height only due to the class frequencies. The area of each bar is calculated by multiplying the width of the class and the frequency. Sometimes people are confused about bar diagram and histogram. The main difference between the bar diagram and histogram is that there is no difference between the bars in histogram, while in bar diagram there is a gap between the bars. Also, the bars in the bar diagram are of equal width, but in histogram it depends on the width of classes and may be unequal due to unequal class width. Also, it should be remembered that histogram can only be constructed for open-ended class width if magnitude of first open class is same as next class and the magnitude of the last class is same as preceding class. The following example helps to get an idea about the construction of the histogram. The data is given in the following table. From the above figure, one can observe that class marks are shown on the x-axis and the corresponding frequency is available on y-axis. The height of the bar is based on the frequency value. Also from the figure 1, one can notice that there is no gap between the bars because values in the tables are shown in. 5. Statistical applications in environmental sciences. Intervals, and there is no gap in the upper limit of one class and the lower limit of the succeeding class. So to represent the continuous data in an exact manner, bars are represented in the figure without any gap. On the other hand, bar diagram is basically used to show the frequency of individual observations. Hence there is gap in the bars due to difference between the observations to maintain the difference. This is the major difference between histogram and the bar diagram. The following example will help to understand the differences between the two in detail. From the above bar diagram, one can observe that there is gap in the bars that justify our discussion on histogram and bar diagram. Hence, one can understand the difference between histogram and bar chart by keeping in mind the above examples. Now, as we are familiar with histogram, another most commonly used method for the graphical presentation of the data is frequency polygon. E. Frequency polygon. Frequency polygon is considered as another method, other than histogram, for graphical representation of the data. It is generally plotted when all the classes have same width. It is obtained by joining the mid-value of the class interval corresponding to the class frequency. The endpoints of the polygon are joined to the x-axis, that is basically the midpoint of classes at end of the 5, 6, 11, 12. 6. Statistical applications in environmental sciences. Frequency distribution. Hence frequency polygon is used in the situation of same class width and covered similar area as histogram. Frequency polygon helps in understanding the skewness property of the data. One can detect the mode value from frequency polygon by drawing a perpendicular from the highest point on the curve to this axis. The frequency polygon of various distributions can be plotted on the same axis for comparison purpose, but this is not possible in the case of histogram. In histogram, if we have to compare two histogram of different data sets, then we require two separate graphs. Also, frequency polygon is a continuous curve and it has other benefits like determination of the slope, rough estimates of a particular value on the x-axis, at what rate observations are changing. Another important feature of the frequency polygon is that it can be drawn without plotting the histogram only when the midpoints of the classes are known. In the following graph shown in Figure 3, a frequency polygon is constructed from Table 1 data. In the graph, one can observe that it is a curve that is represented with the joining of midpoints of class interval and corresponding class frequency on the y-axis. Figure 3. Frequency curve. Frequency curve is the term that is basically used for the presentation of the probability distribution of continuous variable. As continuous variable takes values in small interval and the range of these variables approaches to infinite. So if we decrease the width of class intervals and at the same time increase the total frequency of the data that approaches to infinite, then the shape of the histogram in the frequency polygon is approximate close to the shape of the frequency curve. In that case, the horizontal axis will represent the range of the variable and the vertical axis will show the frequency of a values in an interval. If it is feasible to present the relative frequency of the dataset on the vertical axis, then it shows the percentage of particular class interval. This method of representing the data will help you to understand the concept of probability distribution function in future, where we have probability values on the vertical axis that is derived from a mathematical function. On the other hand, the range of continuous variable is shown on horizontal axis. As the variable is continuous, so the probability of a particular point is 0. So probability are evaluated in terms of intervals. So one can correlate the 0, 5, 6, 11, 7. Statistical applications in environmental sciences. Probability distribution curve and the frequency curve from the concept. The topic of probability distribution function will be discussed in the further modules. As we already discussed about the frequency curve, there are basically 5 types of frequency curves in the literature. These are a symmetrical bell-shaped, B uniform, C U-shaped, D J-shaped, and E asymmetric, positive or negative skew. A symmetrical bell-shaped. In this type of curve, the class frequency values keep on increasing steadily, and after attaining a maximum value it keep on decreasing in the same pace as while increasing. It can be checked whether the curve is symmetric. If we fold the curve from the center, then the two half the frequency curve must coincide. This is the reason that such type of curve is called symmetrical curve, that has same area under curve on both sides of the middle part or center value. Another feature of symmetric curve is that it has single peakness at the middle and lessen slowly on both end. Figure 4. Link for resource. Statistical applications in environmental sciences. B uniform curve. This type of curve will only occur if all the observations have same frequency. So it means when occurrence of each observation in the dataset is same, then such type of curve appear. For example, in Figure 4b, figure represent the score of students of class. If these is a great possibility that all students score equal marks in the class test or examination. In such, the uniform frequency curve will appear. C U-shaped. In this type of frequency curve, the highest value of the frequency occurs at the end or extreme point, and the frequency keep on decreasing as the tilde central part of the data and keep on increasing at the same pace of decreasing before reaching the middle part. This curve is just the opposite of the symmetric curve in shape. In this curve, the most of the values occur at the extreme point and the less values come from intermediate point. D J-shaped. In this curve, the value of the variable attains the maximum frequency at one of its extreme points only. Hence it is different from U-shaped curve, where maximum value attained at both extreme values. In a J-shaped curve, the values has less frequency in the lower class interval, and then frequency keep on increasing steadily as the value of variable increases. Hence at the extreme point the distribution attains its maximum value. E asymmetric. This type of frequency curve has the highest frequency not in the central part of the data but on the either side of the central value. If the curve has longer tail toward the right side, then the distribution is said to be positively skewed. If the curve has longer tail towards the left side, then the distribution is said to be negative skewed. E ogive. E ogive. Ogive curve is constructed from the cumulative values of frequency, i.e. cumulative frequency values are plotted against the x-axis. There are 2 types of ogive curves, less than or more than. Less than ogive curve begin from the first interval and keep on increasing upwards corresponding to the next interval as the frequency are cumulated. That means frequency values of previous frequency are added in next frequency values. Hence it keeps on increasing, and at the last interval it shows the total frequency of data plotted against the last interval. Similarly, more than ogive curve begin from the total cumulative value from the first interval and keep on decreasing at next interval by subtracting the previous interval frequency from the total frequency value. If we repeat this process till the last interval, then one can observe that the curve seem to be like a elongated S and is sometimes called a double curve, with one portion being concave and the other being convex. Also, ogive curve can be constructed for unequal width of classes in the frequency distribution. It is also possible to construct more than or less than ogive curve on the same graph, and one can observe that if both curve are drawn on the same graph, these curve intersect at a point. Z-axis value of that point is the median value of the frequency distribution. Hence ogive curve will help to get an idea about characteristics of the data, as it is only the diagrammatic representation. 9. Statistical applications in environmental sciences. Of the cumulative frequency distribution. There are some of the uses of the ogive, which are as follows. A ogive curve is used to find out the median of the frequency distribution. It is also used to find out quartiles, deciles and percentiles, etc. B. It is used to observe the cumulative frequency of a particular class interval of more than and less than type. C. From the shape of the curve one can observe the number of observations which are expected to lie between 2 given values. It should be noted that it may be possible that one may not be able to estimate the correct value from the ogive curve. Hence, one should be careful while using ogives. An example will help to understand the concept in depth. The cumulative frequency distribution less than type of data used in previous examples are shown below. Class. Marks. In Figure 5, ogive curve represents the cumulative frequency of less than type and it is of increasing type. We use the same data for graphical representation of the more than type of ogive type to see the difference of two type of ogive curve. 511. 22. 10. 30 at x-axis. This 30. From intersection point of these curve draw a perpendicular to the cumulative frequency polygon, horizontal scale i.e. these two curves intersect at point value 49 at y-axis and approximately 30 at x-axis. This approximate value is considered as the median value of the data. In the next section, we will discuss stem and leaf display that is considered as another method for the representation of the data. 4. Stem and leaf plot. 89-85. 7. Statistical applications in environmental sciences. It is considered as an alternative to the histogram. Although it gives a visual representation similar to the histogram, but it does not lose the details of the individual data points in the grouping. For example, the data of expenditure on calls in a week of 30 persons are given below. Table 4. The stems on the left represent the 10 units and the leaves on the right represent the units of ones. So the individual data points can be represented in the diagram. From the diagram, one can observe that it seems like a histogram, but the difference here is that the values are used in place of bars. Hence the major drawback of this diagram is that when we have large amount of then it is difficult to make stem and leaf diagram. In the next section, we will discuss about the diagrammatical representation of the data through the pie chart. 5. Pie chart. When the total values can be represented by a big circle and the various components by sectors cut inside it. This type of diagram is known as pie diagram and it is also used to show the percentage breakdown. The total is represented by 360-degree angle. It can be divided into a number of small angles whose degree is according to the values of the categories in the data. There are some steps for the construction of pie diagram. These are: at the category or items values are expressed either in percentage or degree. For example, number of males females in the data are expressed either in percentage or in degrees. B. One can find the percentage of the items by dividing its value by the aggregate 1 and multiple each of them by 3.6. 12. Statistical applications in environmental sciences. Hence one can find two forms of pie chart, one is in percentage form and other in degree term. For example, the following data represent the expenditure on entertainment and communication of household. 13. Statistical applications in environmental sciences. Figure 8. Hence one can easily understand the expenditure on items through percentages from the pie diagram. This is the reason that pie chart is mostly used to present the data as it is easily understandable even by a layman. 6. Summary. In the real world, large type of diagrammatic methods are used for the presentation of the statistical data. Some of the types are like one-dimensional diagram, two-dimensional diagram, three-dimensional diagram and pictogram, etc. In this module, we discussed some of its types like histogram, bar diagram, frequency polygon, frequency curve, ogives and pie charts. Differences between histogram and bar diagram are discussed. Importance of all these graphical and diagrammatical representation is discussed with examples. Frequency curve and its different types are also discussed. These diagrams and graphical representations are useful as they present the data in an attractive manner that appeal more to the mind of the spectators. These forms are more attractive, fascinating and impressive than the other methods. The best part of diagrammatic representation method is that even a layman can understand this without any previous knowledge of statistics. This is the reason that diagrams, pictures and graphs are used to give primary education to the kids. Statistical applications in environmental sciences. Module 6. Central Tendency Measure SE. Learning objectives. Introduction. Mathematical averages. Summary. Suggested readings 1. Learning objectives. In this module, a complete explanation about different types of measures of central tendency of any data will be discussed. This module will help to understand different methods of central tendency measures and its properties. Through this module, one can learn about which method is to be used under what type of conditions. The topic of central tendency measures is covered in 2 modules. This module will cover the mathematical averages measure of the data. Other topic of positional average will be covered in the module, Central Tendency Measure A. Questions with answers are included to give an in-depth knowledge of the topic. 2. Introduction. In real life, we collect data from population that has same characteristics for a particular objective. The data that are collected contain elements may have different information. Now how we can say anything about the nature of the data. In this scenario, we use a measure that provides an idea about the data. This measure is called Central Tendency Measure. Central tendency is a measure that provides a single value that represents a group of values. However, it should satisfy some certain conditions. There are some properties that are expected from a central tendency measure. I. It should be defined in a rigid manner such that its meaning should be unambiguous. E. It should be calculated on the entire observations in the data. E. It should be calculated in a little time frame and in an easy manner. IV. It should possess mathematical properties so that we can further use it. B. It should not be influenced by the extreme values of the data. B. It must be sensitive to the small changes in the data values. Although while applying the measure on the data, one should keep in mind that the data should be collected from homogeneous group. If the data is not from the homogeneous group, then the value that we get may lead to incorrect decision. For example, while calculating the average height of the students in a class, one should first categorize the gender at first place, after that calculate its mean value on category basis. If students are not categorized according to the gender, then the average height of students lead to unrepresentative form. Hence one can solve this type of problem by categorizing heterogeneous data into homogeneous one. In statistics, three measures are considered generally, that is mean, median, and mode. Mean measure is further divided into three categories: I. Arithmetic mean, E. Geometric mean, and E. Harmonic mean. 4. Statistical applications in environmental sciences. The relationship between different measures are shown below. From the above measures, the arithmetic mean, median, and mode are widely used. On the other hand, geometric and harmonic mean are used in particular situations. In the following section, one can see the complete description of these measures in detail. 3. Mathematical averages. 3.1 Arithmetic mean, AM. Arithmetic mean is among the most widely used measure of central tendency for a single representation of observations. The formula for the evaluation of the arithmetic mean, AM, is given as arithmetic mean, AM equals sum of all observations. Number of observations. Let x1, x2, xn be n observation is a data set. The arithmetic mean of the data is denoted as x. X equals n array summation xi. N. I equals 1. N. For example, let 23, 24, 25, 35, 32 be 5 class size of different sections of 9th class in a private school. We want to know about the average class size in 9th class. To calculate this, we first calculate the sum of all class sizes and divide it by no of sections. The arithmetic mean is 27.8 approximately equals 28. It means that there is approximately 28 students on average basis in each class. Measure of central tendency. Mathematical average, positional average. Arithmetic mean, AM. Geometric mean. Harmonic mean. Median, quantiles, mode. 5. Statistical applications in environmental sciences. This method cannot be applied if the no of the elements in the dataset are very large. For the convenience purpose, frequency tabulation method is used. One can recall the tabulation methods from the previous modules. Let x1, x2, xn have frequencies f1, f2, fn respectively. That means that in the complete data set x1 appears f1 times and x2 appears f2 times, and so on. Hence the formula for AM in this case will be x equals f1 x1 plus f2 x2 plus fn xn. f1 plus f2 plus fn. This method of calculating arithmetic mean in term of frequencies is known as weighted arithmetic mean, as we are multiplying the xi, s with their corresponding frequencies fi. An example consists of no of child in 50 families in a locality as presented below will give you a better understanding of the weighted arithmetic mean. No of child 0, 1, 2, 3 or above families 10, 1, 5, 2, 0, 5. Table 1. Now to calculate the average number of child in a family. One can use weighted arithmetic mean and the value is 1.4 approximately equals 1. Hence on average there is a single child in each family. Also in real life, we have large amount of data, so as we know from the module, diagrammatic and graphical representation of the data, that in such type of cases, one can construct frequency table. For example, we are interested in the marks of the students spending hours on daily basis to learn through online program. The artificial data was available of 1,000 students and information is given in the following table as time spent in hours, number of students 04690. 4. 6. Statistical applications in environmental sciences. But here x1, x2, xn are the midpoint of class interval, so the arithmetic mean of the data can be found as equals 2 asterisk operator 690 plus 6 asterisk operator 285 plus 10 asterisk operator 20 plus 14 asterisk operator 5690 plus 285 plus 20 plus 5 equals 3360. 1000 equals 3.360. Hence from the above example, we can conclude that 3.36 hours or 3 hours and 6 minutes on average are spent by the students on daily basis. Now we will discuss about the merits and demerits of arithmetic mean AM. As arithmetic mean is widely used in literature due to the following merits. Merits. AM can be easily understood by a person and does not require any particular need to explain it. B. The calculation of the AM is very simple and does not require any calculations. C. It is derived without ordering the data like other measure of central tendency. D. It is considered as comparative very stable and good method of central tendency in comparison to other measures. E. If one has large amount of data, then it is considered as a good method of central tendency as the unusual observations in one direction can be offset by the unusual observations in other direction. Demerits. There are also certain shortcoming of any measure and AM is not an exception. There are some important demerits of AM given below. AM cannot be obtained through guesses like other measure, mode, etc. Whether it is not considered as a major demerit, but still it is. Also, median can be located graphically, but AM cannot. B. AM cannot be found for the data when one has missing observation in the data. Also, for a small set of data, it is highly sensitive to extreme values. In such cases, AM will lead to wrong conclusions. C. AM cannot be evaluated for the qualitative characteristics that cannot be measured, like sex, level of illness, etc. In such cases, it is suitable to use other measure of central tendency like median. D. It may be possible that a value calculated through AM is difficult to interpret. For example, one can recall the value of AM evaluated from table 1, which is 1.4, that has no interpretation as child is considered in unit, not in fraction. So the 1.4 child is meaningless. E. It is possible that it may lead to false conclusions. At the last, one can say that AM is considered as a simplest measure of central tendency, but it will mislead you when data are of heterogeneous form, i.e. non-homogeneous. 7. Statistical applications in environmental sciences. 3.2 Geometric mean. Geometric mean is another method to find out the mean of n observations. It is evaluated through the following method. Let us suppose x1, x2, xn are n observations, then G m equals x1, x2, xn, 1n. If x1, x2, xn have frequencies f1, f2, fn respectively, for evaluating the GM, the method is G m equals x1, f1, x2, f2, x3, f3, xn, fn, 1n. Where n equals n area summation fi is the sum of all observations frequency and is called the total frequency. Hence, one can use the above method to find the GM of the observations. It is difficult to find out the GM by using this formula, or one can use the above formula when the no of observations is very small. In this case, one can use log on both sides of the formula. Then the modified form, the above formula, are given below respectively. Log m equals 1. nn area summation log xi 1. Log g m equals 1. nn area summation fi log xi 2. Now, if one is using the formula of equation 1 and 2, then one has to take antilog at the end to find out the GM value. G m equals antilog 1. nn area summation log xi 3. G m equals antilog 1. nn area summation fi log xi 4. Steps for the calculation of the GM for simple data using equation 3. Calculate log base 10 of the observations. E. Take the sum of all log of observations, i.e. n area summation log xi. E. To find the log GM, divide n area summation log xi by total no of observations. IV. Take antilog base 10 of 1. nn area summation log xi, and this is GM of the required data. Case 1. Find out the GM of the following data given as 34, 57, 37, 43, 52, 67, 54, 56. As in table 3, the log values are shown in second column. From the above data, the required value is calculated as 48.86079. Now to find the GM of the data when the data set has frequencies with them. There are further two cases. A discrete case, ungrouped frequency series. B. Continuous case or class interval, grouped frequency series. In the first case, observations are given with their corresponding frequencies. In the second case, as data is given in the class interval. In these two cases, the GM is calculated in a different manner. Discrete case. GM for the discrete case is considered first. One has to follow some steps given below to calculate the GM. Steps are: calculate log base 10 of the observations. E. Multiply the log values with the corresponding frequencies values and take their sum, i.e. n area summation fi log xi. E. Divide the term, i.e. n area summation fi log xi by n, that is the total frequency. IV. Take analog base 10 of 1. nn area summation fi log xi. This will give you the value of GM for frequency. Data. Case 2. Find out the GM of the following data given as: Table 5. In the table 5, data values are given in the first column and their corresponding frequencies in the second column. Logarithm of observations are calculated in the third column. Fourth column represents the values of product of logarithm values corresponding to their frequencies. 88.1565848 represents n area summation fi log xi, and 1.695318928 is calculated by dividing 88.1565848 by NIE 52, and 49.584163 is the analog of 1.695318928. Hence the G. Continuous case or class interval. If the data is of continuous form, then one has to first construct frequency table using class intervals. Then only one can find out the GM for the continuous data. There are few steps for calculate GM in these cases. These steps are: first calculate the midpoints mi of the class intervals. Calculate log base 10 of the mid values of each class interval, i.e. log mi. Multiply the log values with the corresponding frequencies values and take their sum, i.e. n area summation fi log mi. IV. Divide the term, i.e. n area summation fi log mi by n, that is the total frequency. 10. Statistical applications in environmental sciences. B. Take analog base 10 of 1. NN array summation Fi log Mi. This will give you the value of GM for frequency. Data. Case 3. Find the GM of the following data. Mid values are calculated. In the table 7, first column represents the class intervals and their corresponding frequencies are given in the third column. Mid values are calculated in the second column and logarithm of mid values are calculated in the fourth column. Fifth column represents the values of product of logarithm values corresponding to their frequencies. 35.61587367 represents n array summation Fi log Mi, and 1.0792688899 is calculated by dividing 35.61587367 by NIE 33 and 12.00242219 is the analog of 1.0792688899. Hence the GM is calculated as 12.00242219. Hence, one can use the above steps for calculating the GM in continuous case. 11. Statistical applications in environmental sciences. As we are using the GM as a measure of central tendency, one must know where to use this measure to get more appropriate information. Hence it is essential to discuss about the merits and demerits of this measure. Merits of GM. A. It is defined in a rigid manner. B. It is based on all the values of the data and cannot be calculated for data with missing values. C. GM can be calculated in those cases where only the total product of observations and number of observations are known without having knowledge of individual values. D. GM can be used for further mathematical treatment like rations and percentages. Therefore it can be used for further analysis like index number, etc. E. The main advantage of GM is that it is not affected much by extreme large and small values, and it gives more weight to small values in comparative to AM, which gives more weight to large values. Demerits. There are few demerits of GM. These are: A. Due to the complexity involved in the calculation of GM. It is difficult for a non-mathematical person to understand it. B. The calculation of GM requires the knowledge of logarithm that is difficult for a non-mathematical background person. C. GM cannot be calculated for the data which contain a value 0. D. GM is not useful for the data that have different signs, that is, some of the observations are positive and other are negative. In such case, GM value has no meaning. E. GM value may not be the actual value of the observations like other measure of central tendency. F. GM is not advisable to use in those cases where small observations must be given more weights and higher observation must be given less weights. Another measure of central tendency is harmonic mean, HM. This measure of central tendency has a great importance in science and mathematical field. 3.3 Harmonic mean. Harmonic mean is calculated by first taking the reciprocal of the observations and then taking the reciprocal of arithmetic of these reciprocal observations. Let us suppose x1, x2, xn are n observations in the dataset. Then 12. Statistical applications in environmental sciences. H m equals n 1 x1 plus 1 x2 plus 1 xn equals n array summation 1 xi dot. When observations are given with frequencies, i.e. x1, x2, xn with f1, f2, fn are the corresponding frequency values, then the hm is evaluated by using the following formula. H m equals f1 plus f2 plus fn f1 x1 plus f2 x2 plus fn xn equals n array summation fi xi, where n equals n array summation fi is the sum of all observations frequency and is called the total frequency. Harmonic mean is basically used in the case where rates and ratio are involved, like per hour, per month, per liter, per minute, etc. It is used for to find out the average of different types of rates. These rates are basically used to explain the relationship between two units of opposite nature, like as you increase the speed of a vehicle, then this shortens the traveling time. Hence HM is used to find out the average speed in kilometer per hour for a given distance. In the following example, HM is evaluated to find out the average speed of 6 cars given in kilometer per hour. Case 4. Calculate the harmonic mean HM for the series 56, 45, 67, 58, 53, 42. ANS. KMPH. KM. $12. In Table 8, the reciprocal of observation are given in the second column. 0.1149235666 represents the total of reciprocal of the observations and 52.2086 is the HM of the data. Similarly, one can keep the following steps in mind to find out the HM for observations given with frequencies. These are: for ungrouped frequency data, steps are 13. Statistical applications in environmental sciences. I. Find out the reciprocal of the observations. E. Multiply the reciprocal observations with the corresponding frequencies values and take their sum, i.e. n array summation fi xi. E. Divide n by the term, i.e. n array summation fi xi, where n is the total frequency. IV. This will give you the value of HM for discrete frequency data. For grouped frequency data, steps are: I. First calculate the midpoints mi of the class intervals. E. Multiply the reciprocal observations with the corresponding frequencies values and take their Sum IEN area summation Fi per meter I. E divide n by the term IEN area summation Fi per meter I, where n is the total frequency. This will give you the value of HM for grouped frequency data. Hence, one can evaluate the HM for three different situations, i.e. simple, discrete frequency and grouped frequency. Now, we will discuss the merits and demerits of the HM. Merits. A. HM is defined in a rigid manner. B. HM is evaluated on all the observations in the data. C. HM gives less weight to large values and more weight to small values, so this measure is appropriate in those cases where such condition is required. D. HM is used to measure relative changes and is widely used for the averaging of ratio and rates. Demerits. A. HM is very difficult measure to be understood by a non-mathematical background person. B. HM is comparatively difficult to calculate than other measure. C. HM cannot be evaluated if the value of the observation is 0. D. HM cannot be evaluated when some of the observations are positive and some are negative in the data set. E. HM value does not exist in the data set. Relationship between AM, GM and HM. A.M.is always greater than or equal to GM and GM is greater than or equal to HM for a given observations. In mathematical term, A, M, is greater than or equal to G. M, is greater than or equal to H. M. These measures are only equal when all the observations are same in the data. 14. Statistical applications in environmental sciences. 4. Summary. In this module, three measures of mathematical averages are discussed that is a branch of central tendency of measures. It is generally termed as mean in the literature. In this module, we discussed about which measure of mean is more suitable to which situations. We also discussed how to evaluate different types of means like AM, GM and HM for different types of data like simple, frequency data and group frequency data. Merits and demerits of all three mean and relationship between them are also discussed for better understanding.